In this video, I'm going to go through an example and sort of use it to talk a little bit about how we incorporate learning in when working with LLMs. And it's not really having the LLMs learn because once they're they're trained, that's it. So their training is complete once they're produced by whichever company produces them, whether it's Claude or OpenAI and so forth. We are just consuming them through an API, and in this example, sort of using whatever training is in there to see if it can produce useful code for us that we can use to talk to databases, right? So that's what we're trying to do here. So it's not really that the LLM is learning so much that the way we use it, the workflow, can be, if it makes an error, can we introduce some kind of process so that it doesn't make that error, the same error in the future? So in other words, it kind of learns from its mistakes. Okay, so okay, so let me kind of go through that here. So I'm going to select SQL. I'm going to switch to what, so it finds that, oh, I have this server on my laptop here. So it just pulled that in. I'm not going to specify any database. Once again, hopefully it'll find the right one based on the question I ask. So here, once again, I'm going to be using the free Meta Llama model from a provider called OpenRouter. And I'm going to ask a question. So give me the top 10 drugs in terms of amount paid by self. So amount paid by individuals themselves for individuals with diabetes. Okay, so that's the question I'm going to ask. I'm hoping that it understands that this is sort of a healthcare related question. I have different uh, databases on my local SQL Server. One of them is called MEPS. So it's a medical expenditure panel survey. It's free public data set. And so I'm going to ask those questions, and let's see if it can figure out what I'm asking about and produce some code that's useful. Okay, so here it did find that MEPS was the right database to ask the question of, and produces this code. And this code looks good to me, actually. So I don't have any corrections here. And by the way, I think this kind of workflow where I ask a question, it produces an answer, and it shows me the code, and I can review the code, I can edit it, and then run it, I think is super important. The ultimate vision is that one day we can just ask the question that like I just asked, and it's just so smart that it understands me and understands my all my databases, and it can just one shot it, right? So it can just give me the right answer. I don't have to look at code. I don't have to look at how it came to the right answer. It just gives me the answer. And I have some degree of trust in it, like I would in, say, another human who is a good analyst and whose work I trust. I have tried all of these tools, and I continue to try them. I mean, this is the one that I'm building, but I've tried all the other ones available, and we are not there. we we are not at a point where we can just kind of ask a question, get an answer, and trust it. So I think it's really important to have this kind of a split screen view, where we get the code and we are like, we can take a look at it. Even if I'm not a coder. Um, let's say I have some familiarity with the database that I'm asking the question of. Maybe I've looked at a document about it. Maybe I've glanced at the data dictionary and I'm interested in some quantities. And I know that this is the right column for total amount paid by self. Um, so let me run it and see if the code itself actually works. And it does seem to work. And we get the answer. The other reason this kind of split view is important, I mean, actually the same reason, is that real databases are messy. Um, you could have five different columns for cost, and you ask a question like this, and you might get an answer that looks reasonable. You're like, oh, these are the drugs I would possibly suspect, and I'm getting the amounts. The amounts look like, yeah, that's possibly correct. But if you don't know which exact columns it used, and how it identified the diabetics, I mean, it might be using one cost column that's 10% different than the other, but the other one was correct. You would just never know that the answer you got was not, a perfectly correct answer. So that's why it's really important. Okay, so I think in this case it gave me the right answer, so I don't have anything to correct it with. So let me ask a different variation on that. Amount paid by insurance. Okay. Okay. All right. So now it gives me a different cost variable here. Okay. So RXPV 19X as total paid, amount paid by insurance. This isn't wrong, but it's incomplete because when we're looking at insurance, it's actually not just that column. And I'm familiar with this data set, so I know that there are a few more things to add there. So I'm going to edit it and add another column, RXOF. So this is amount paid by other insurance, RXOT 19X, RXMR, amount paid by Medicare 19X. And I think that was it. Oh, there's also state paid RXSL. So, yeah, so, these things can get complicated. So, RXSL 19X. So there's a bunch of different columns if you're trying to get amount paid by total insurance. In this case, I mean, obviously you can say that the original answer was correct because it was giving me private insurance, RXPV, and maybe that's what I meant by amount paid by insurance. But let's say I mean, um, Medicare and state and other insurance and all these things. Let's say that's what I mean by insurance, which, you know, is a different and possibly flawed interpretation, but let's say that's what I meant, and run and get an answer and say, I like this answer, like this is good. And I wanted to understand that for next time. So I'm going to click on train. Okay, so this is another way we can incorporate learning into the process. And what this will do is it will store this question that I asked and this code that it produced as a sample, as a training sample. Okay, so let click on train. So it says example save successfully. Okay, so now the theory is that the next time I ask this question, so let me ask this question right now, instead of just giving me the private insurance, I have trained it to know that, for this database, if I'm asking a question like this or a similar question, then give me all those other columns as well. And that's what I mean by insurance. So if I run the same query, um, now I get all those different columns again. So it learned, right? So it learned um, the question I asked, and now it gave me the right one. Uh, uh, all the different columns of insurance or pairs, I guess, and that's the answer I got this time. So this is how we can incorporate kind of what a given individual means by a given question, right? Because the language, as much as we like to think so, these are all based on natural language. Natural language is not precise, and when we're talking about databases and context, that's requires some precision, and that will depend on who the subject matter expert asking the question is and what they mean by certain words, and so forth. So this is a way where you can incorporate all of that by training. So you ask a question, you don't get the right answer, you ask it again, or you fix it manually, and then you can train it. And then the next time you ask that the same question or a similar question, you get the correct answer. So, for example, here, instead of asking my diabetes, I could possibly, let's see if it works. By the way, I haven't tested any of this out, so uh, it may not work. LLMs tend to be unpredictable a little bit anyway. But let's say a change from diabetes to arthritis and see if it can still, yeah, it seems like it did find the right variable to identify arthritis. It's still getting the right columns uh, to call insurance. So yeah, it did seem like it worked. I can get it to express as pie chart just to ask a follow-up question, so it can add some kind of plotting to give me the results in terms of a pie chart. Okay, so yeah, so I think I've talked long enough. It's in one of the longer videos, but I just want to talk a little bit about the different places where we can incorporate you know in intention, context, and sort of learning from a given query, so that any subsequent query can be will have that context. Another big way that we incorporate context in this kind of an application where we're using an LLM to talk to databases is of course the data dictionary. And I'll talk about that in a future video as to how that kind of comes into play. That's a really important building block of any kind of workflow like this as well. So I'll talk about that in the future video. So anyway, I think I've rambled on long enough. If you have any thoughts, comments, please share below. Any experiences, always happy to learn from others. And yeah, I'll see you in the next video. Thank you for watching.